Yes, in the last class, we are discussing about the important concept that is prefix codes and the weighted trees. Okay, that is this concept is very important as per the examination point of view. Okay, on this concept there will be one question that is for A2, then next question. Okay, already we have discussed some of the important things here. Okay, prefix code. First, you should know the meaning of the prefix code. Okay, already we have gone through the definition of the prefix code. Okay, here you see, let P be a set of binary sequences that represent a set of symbols. Okay, then P is called a prefix code if no sequence in P is the prefix of any other sequence in P. Okay, if P is the set of binary sequences. Okay, if P is equal to sum of the binary number 0, 1, okay, it is having the sum of the possible combinations of the zeros and ones. P is equal to sum of the possible combinations of the binary numbers, that is zeros and ones. Then P is called the prefix code. Okay, if no sequence in P, okay, is the beginning or prefix of any other sequence in P, then we are going to call, okay, given a sequence of binary numbers are going to be called as a prefix codes. Okay, for example, you see here P1 and P2, A1 and A2 are the sum of the sequences, sum of the given sequences of the binary numbers A1 and P2 and A1 and A2. Okay, here P1 and P2, okay, he has given both are prefix codes. Okay, both are prefix codes. Okay, you see the definition of the prefix code here. Prefix code, okay, is a code in which no sequence is the beginning of the any other sequence in the given list. Okay, here you see 0 1 0 double 1 0 1 triple ones double 1 double 0. Okay, here you see each and every sequence. Okay, okay, all these sequences are not the prefix of any other sequence in the given list. Okay, this list is having some of the sequence of binary numbers 1 0 0 double 1 0 1 triple ones double 1 double 0. Okay, you see each and every sequence, okay, is not the prefix or is not the beginning of any other sequence in the given list. Okay, 1 0, you see this 1 0 is not the beginning of any other sequence. You see 0 is there, yes, it is not the beginning. Double 1 is there, it is not the prefix. Triple ones are there, so that it is not the prefix of this one. Double and double 0 are there, so that it is not a prefix of this one also. And you can check each and everything here. 0, yes, 0 is not the prefix of any other sequence in this list. Leave it. Next one, double 1 0 1. Okay, you see this double 1 0 1 is not the beginning of any other sequence in the given list. Yes, two are there, yes, only one element is the leave it. Triple ones are there, leave it. Double 1 double 0 are there, leave it. So that this is not the prefix of any other sequence in the given list. Okay, and coming to the triple 1, okay, you see this triple 1, okay, will it be the any beginning of any other sequence? Triple ones, no, 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 no. So that this triple 1 is also not the prefix of any other sequence in the given list. Okay, last is there, that is double 1 double 0. Okay, so that this double 1 double 0 is also not the prefix of any other sequence in the given list. You can verify it. So that this P1 list is having the sequence of binary numbers. Okay, are all are not the prefix of any other sequence in the given list. So that this P1 is a prefix code. This P1 is a prefix code. Okay, in the P1 list, okay, all the sequences are not beginning of any other sequence in the given list. So that P1 we are going to call it as a prefix code. Okay. Next, you see here P2. You can verify all the sequences of P2 list, whether any of the sequence is prefix of any other sequence in the given list. Okay, triple zeros are there. Okay, triple zeros are there. So, okay, so that here double zero are there. Leave it. Only one zero, leave it. No zeros, leave it. No zeros, leave it. So that this is not the beginning of any other sequence in the list. Leave it. Coming to the second sequence, double zero one. Okay, double zero one. You can verify with all the sequences in the given list. Double zeros are there. Leave it. Zero one, leave it. One zero, leave it, and double one, leave it. So that this is also not the prefix of or beginning of any other sequence in the given list. Next, 01 is there. Verify with all the sequences. Triple zero is leave it. Double zero, one is there, leave it. 10 is there, leave it. Double one is there, leave it. So that this is also not the prefix of any other sequence in the given list. Coming to the next sequence, that is 10. Okay, verify that this 10 will be the beginning of any other sequence in the list or not. Okay, here is it. Triple zeros, no. Double zero one, no. Zero one, no. And double one, yes. This is also not the prefix of any other sequence in the list. Last is there double one. Verify, no, 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 and no. So that all the sequences which are there in the list P2 are not the beginning of any other sequence in the list. So that P2 is also the prefix code. So that P2 is also the prefix code. Okay. Then P1 and P2 are the prefix code because all the sequences which are not the beginning of any other sequence in the list. You can verify each and every sequence with the other sequences in the list. Okay, you can verify each and every sequence in the list with other sequences in the list. Okay, and all are not the beginning of any other sequence. So that P1 and P2 are the prefix codes. Okay, and coming to the one more example, A1 and A2. Okay, here you see in the A1 is having some of the elements, okay, binary numbers 0 1 0 101 10 and 1. Okay, you verify here 0 1, just wait. Yes. Yes, A1, you see all these sequences, okay, whether any sequence is beginning of linear or sequence. Okay, first I am going to continue with the first element in the list, that is 0 1 is there. You just verify this 0 1 will be the beginning of any other sequence. Here 0 is the leave it, 1 0 is the leave it, 1 0 is the leave it, yes 1 is the yes, so that it is not the beginning of any other sequence in the list. And coming to 0, second element is 0, 0 is there. So you see here this 0 will be the beginning of this one, this 10 is there, no, this 0 will be the beginning of this sequence, so that this 0 will be the prefix of this sequence. Okay, and this spells the condition of prefix codes. Next one, 101 is there. Okay, 101, it is not the beginning of any other sequence in the list, leave it. And 10 is there. This 10, okay, will be the beginning of this 101. You see here, this 101 sequence is there, no. Okay, beginning 10 is there. Okay, this 10 will be the beginning of this 101 10, so that this A1 will not be the prefix code. This will A1 will not be the prefix code. Okay, coming to the second example, that is A2, 1 1 1 1 1, yes, it is not the prefix of any other sequence. Okay, next 0 0 is the double zeros are there. Yes, you see here, yes, triple zeros are there, so that double zero, okay, this is the prefix of this sequence. Next one, 001 is there, so that this is the prefix of this one. Okay, and next one, 10 is there, so that this 10 will not be the prefix of any other sequence. Okay, next triple zeros are there. Here you see 0001, so that this 000 will be the prefix of this 0001, so that here this one and this one, okay, are not satisfying the condition of the prefix code. So that this A1 and A2 are not the prefix codes, are not the prefix code. I hope that you have the clear idea of what do you mean by prefix codes. Okay, what do you mean by prefix code? Let P is called the, okay, P is called a prefix code. Okay, if no sequence in P, okay, if no sequence in P is the prefix of any other sequence in P. Okay, if P is the prefix, if P is the sequence of some of the elements, okay, and no sequence in the list. If P is the list of some of the sequences, okay, in that list, no sequence is the beginning of any other sequence in the list. Then the given P is called a prefix code. Then given P is called a prefix code. Okay, all these things are will helpful for encryption and decryption or encoding and decoding of the information for the security reasons. Yes. In last class also we have discussed how to construct full binary tree by using the uh, given values. Okay. Mm, yes, in this he has written the symbols with sequence numbers in the pencil. To leave it this example and coming to this example. Okay. Uh, Consider the prefix code. Okay, consider the prefix code A, B, C, D, E. Okay, A, B, C, D, E are the sum of the symbols having the prefix codes. Okay, triple ones, 0, double one, double 0, double one, 0, 1, and 1, 0 for the symbols A, B, C, D, E respectively. Okay, the question is using this code, decode the following sequences and draw the binary tree that represents the prefix code. Okay, we are going to draw the binary tree. Okay, we are going to draw the binary tree for this sequence of the symbols here. Okay, first you see how to draw the binary tree. Okay, how to draw the binary tree. Yes, first you see we have to draw what is that. He has given what a is equal to some value, some sequence of binary numbers. B is having some number, some binary number. C, D, E. Okay, all the symbols are having some of the sequence of binary numbers. Okay, by using them, we are going to decode. Okay, this is a sum of the sequence of binary numbers. Okay, we are going to decode it. Okay, we are going to decode it by using these all these symbols here. Okay, here you see first one is there, one. Okay, first you see one, single one is not there. Here you see. Okay, first you have to move with the uh, one element. First you see one is there. We check each and every symbol whether any symbol is having one or not. Yes, one. Here triple ones are there. Leave it. Only one I want. No, 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 no. All are not having the single one. Leave it. Then after that you combine one more digit, one more number. That is 10. You check whether any symbol is having 10. No, 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 no. Yes. E is having 10. Yes or no? This 10, okay, the representation is done by the symbol E. So that you write E here. So that first two digits are over, leave it. Then next 0 is there. First two digits are over only. Okay, first two digits are represented by the symbol E. So that leave it for first two digits. The next one is third one, 0 is there. We check 0, single 0, whether any symbol is having single 0. No, no, E is not having single 0. Leave it. B, yes, B is having single 0. So that for this number we are going to write B here. Yes, B, I have written B here. Okay, over. First three digits are over. Then next one is 1 is there, single 1 is there. You search single 1 in the given symbols. No, 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 no single 1 is there. Leave it. Then you combine one more digit. double ones. You see whether any double ones are there. No, 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 no double ones are there. Leave it. Okay. Next, you combine one more thing here. That is triple ones. You check triple ones in the given symbols. Yes, A is having the triple one, so that I am going to replace this triple ones by the symbol A here. This triple ones by the symbol A. Now I have completed 6 digits. Okay, for these 6 digits I have written the corresponding symbols EBA. EBA. Then the remaining the symbols are 1101. 1101. First you check. Yes, for 1101 I have the symbol D here. For double one, you see here, first you again the same procedure we have to follow. First go with one. One is not the respect to any symbol, leave it. Next double one is there, no double ones are there here, leave it. And double one zero is there, you check double one zero here, no double one zero, no. Yes, after that I have double one zero one is there, so that the last one is double one zero one is there, so that double one zero one is held by the symbol D here, so that I have written D. So that for this sequence of binary numbers, the decoded message will be EBAD. The decoded message will be EBAD. Correct? He has given some of the symbols with some of the sequence numbers. Okay. After that, he has given some binary sequence string. Okay. After that, we have to decode that binary sequence with a given data. Okay. First, you have to search with each and every individual binary bits in the given thing here. One, search with all the symbols, whether any symbol is having the one or not. Yes. Okay. And do the same procedure until you get the last digit in the given sequence of binary numbers. Okay. This is what the answer for using this code decode the following sequences. Using this code decode the following sequences. Okay. And similarly, you see here BC. Okay, you do the same procedure. Okay, you see here first element is A, one is there. You check each and every symbol, one, no one is there. Then you add one more digit, 10, 10, 10, 10, 10. Yes, 10 is there. That is held by the symbol E. I have written E here. Next, again one is there. One is not having. Okay, now it is not with respect to any symbol. Leave it. And again you add one more one to that one. Double ones are there. No double ones are there. Leave it. And triple ones. Okay, yes, these triple ones are held by the symbol A, so that I have written A here. Okay, these 5 elements are over. The next will be the one. Again, one is there. One is not with respect to any symbol. Leave it. 10. Okay, this 10 will be held by the symbol E, so that I have written E here. Okay, next 0 is there. You say check 0. Whether any symbol is having 0, yes. B is having 0, so that I have written B here. Okay, for all these, okay, the respective symbols are E, A, E, D. Now the next digit is 1. Yes, 1 is not having any symbol, leave it. And again double ones. Okay, these double ones are not associated with any symbols, leave it. Next double one 0 is there. You check whether any symbol is having double one zero, double one zero, double one zero. No symbol is having double one zero. Next, double one double zero. Yes, we check whether any symbol is having double one double zero. Yes, C is having double one double zero, so that I have written C here. Okay, for all these, the decoding is over. For all these, decoding is over. The next symbol is in the sequence is 0. Again 0. Either any symbol is having 0, yes. B is having 0. Yes, B is having 0. I have written B here. Okay, for all these, decoding is over. The next one is 1 is there. Yes, 1 is not with respect to any symbol, deviate. Next, add one more digit, double ones. Yes, these double ones are not the are not associated with any symbol, deviate. Next, double one zero. These double one zeros are not associated with any symbol, deviate. Next, last will be double one zero one. Yes, this double one zero one, okay, is with respect to the symbol of C. So that I have written that is double one zero one is with respect to the D here. The symbol D is having the sequence number, that is double one zero one. So that I have written here double one zero one. For that I have written D. So that for this sequence, after decoding, we have got this is a message here. That is E A E B C B D. Just wait for a while. Yes, in this way we have to encode the given sequence of binary numbers. Okay, he will give some of the symbols with specific sequence numbers here. Okay, by using this, in this way we are going to decode them. Okay, after that we have to construct, draw the binary tree. Okay, that represents the prefix code. Okay, draw the binary tree for this prefix code. Yes, all of you mute your audio. Yes, for this, first we have to for this, draw the binary tree that represents the prefix code. Okay, for this prefix code, we have to draw the binary tree. Okay, for that, first we should construct the full binary tree. First we should construct the full binary tree. In the full binary tree, each and every leaves, each and every leaves in the tree are having the height is equal to h, or having height is equal to h. Here h stands for the maximum height of the tree. Here h stands for maximum height of the tree. Okay, first we should construct the full binary tree. In the full binary tree, all the leaves means what here? The vertex with out degree is equal to, or you can call it as a vertex with degree 1 is called a leaves in the tree. A vertex with or pendant vertex, or you can call it a leaves in the tree here. A vertex with degree 1, a vertex with degree 1 is called a leaves in the tree. Okay, or with respect to graph theory, we are going to call it as a pendant vertex. A vertex with degree 1, the number of edges which are lying on that vertex is called the degree of the vertex. If it is 1, if only one edge is staying on that vertex, then we are going to call it as a degree 1. Yes, degree 1. So that in the given tree, if any vertex is having degree 1 in the tree, if any vertex is having degree 1, then that will be called as a leaves in the tree. Okay, first we should construct full banana tree. Okay, in the full banana tree, all the leaves in the tree are having the, okay, all the leaves in the tree are having the height is equal to h, maximum height of the tree. Okay, how to find the maximum height of the tree? Okay, you see the given sequences a b c d e are there, no? Okay, the maximum length of the sequence will be 4 only. Here you see the length of this a will be 3, the length of b is 1, the length of c is 4, the length of d is 4, the length of e is 2 here. So that the maximum length of this sequence is 4 only. So now c is having 4 and e d is having 4. So that the maximum height of the tree will be 4 here. Okay, so that we should construct first full banana tree with a height 4. You see here, r will be the root of the tree here, 0 level, 1 level, 2 level, level 3 and level 4. You see the cursor to where I am pointing to now, you see that one. Level 0, level 1, level 2, level 3, level 4. Okay, so that the height of the tree will be 4 here. The maximum height of the tree will be 4. Okay, here you see. What is full banana tree? All the internal vertices are having the childs 2. Okay, here you see root node is having 2. Okay, these are in all the internal nodes, all the internals are having the two subnodes. Okay, left node and the right node, or you may call them as a childs. You may call them as a childs of that node here. Okay, you see r is a root node, it is having the two nodes. This one, all these internal nodes are there now, are having the two nodes, left node and the right node. Okay, and here you see, okay, all the leaves, okay, a vertex with degree 1 are called the leaves in the tree. Okay, a vertex with degree 1 are called the leaves in the tree. All are having the degree 1. Okay, this is the first initial step. This is the first initial step. Okay, after that, after that, okay, put zeros and ones. Put 0 over the edge, over the left edge, and put 1 over the right edge. Here you see this 0 is there now. Put 0 over the left edge and over the 1 over the right edge. Do the similar process for all the edges in the given tree. Okay, do the same process for all the edges in the tree here. Okay, 0 over the left edge and 1 over the right edge. But in this diagram here is not represented. Okay, just to write here, write 0 here, 1 here, 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1. Okay, for left node, okay, for left edge, okay, on that write 0, and for the right edge, okay, write 1. Okay, after that, this is the second step. Okay, first, according to the height of the tree, we should construct full binary tree. Okay, after that, for each node, for each edge, for each left edge in the given tree, write 0 over the respective left edges and 1 over the respective right edges. Here you see, here written, no, here in the same 0 1 0 1. In this example here written this here 0 1 0 1 0 1 0 1. Okay, for all the left edges he has written zeros, and for all the right edges he has written once. You see this diagram. Okay. Similarly, we have to do the same process for this one also. In this example, he has not written each and everything. Okay. What he did in this previous example, no. In the same way, we have to follow the same procedure for this diagram also. Okay. Once if you done with this step, then we have to write all these things. Okay, for this what he has asked, draw the binary tree that represents the prefix code. Okay, this is a prefix code now. Okay, for this prefix code we have already got the message EBAD. For this prefix code we have decoded and we have got this message, that is message is EBAD. For this message we have to construct binary tree. Okay, for this message we have to show that message with the help of the binary tree. Okay, what are the steps? Okay, first we should construct the full binary tree. What is full binary tree? In the tree, if all the leaves in the tree are having degree 1, then that tree is called as a full binary tree. Okay, uh, how to, what will be the height of the tree? Okay, depending upon the maximum number of binary sequences in the given symbols. Here you see C is having 4, D is having 4. The maximum symbols, the maximum sequence numbers will be 4, no? So that I have chosen the height of the tree will be 4 here. 0 level, 1 level, 2 level, 3 level, 4 level. Okay, this is a height of the tree. Okay, after that, okay, you construct the full binary tree. Okay, for a full binary tree, okay, the for each root node, for the root node and all the internal nodes are having the two nodes, left node and the right node. Yes, like this we have to construct. After that, for all the left edges, for all the left nodes, put 0 on that respective edges. And similarly, for all the left right edges, put 1 for all the respective right edges here, like this. Yes, zeros for all the left edges and ones for all the right edges here. It's here 0 1 0 1 0 1 0 1. Yes, like this we have to do. After that, how to construct uh, binary tree for this message? First, E is there, EBAD. EBAD is there, no? E is there. What is the sequence of binary numbers for E? What is E? 1 0. Okay, for E 1 0 is there. Okay, you should trace the path. You should trace the path. Okay, over the edge that is having the values 1 and 0. Okay, you should trace the path that is 1 0 over the edges. Okay, in the given binary tree here. Okay, 1 is here. Okay, you start to always start with the root node. Root node is R is here, 1 0. Okay, for 1 where should I go? Okay, I should go to the right node. Yes, right node. Okay, after 1 I have 0. Where should I go? 0 is for left node, no? I should go to E here. So that for this node you should write E here. Okay, 0 1 0. He has not written 0 here, don't worry. Okay, for 1 0, for 1 I should move to right node. After 1 I have 0. Okay, 0 for left node, no? So that I will move to the left node. Okay, to this point. Okay, I have to label this node as E here. I have to label this node as E. That is over. Okay, next B is there. Okay, what is the sequence of binary numbers for E here? B is 0. Okay, okay, starting with root node 0. Where should I move? I should move to left node, no? Yes, 0. Only one value is there, 0. So that for this node I label this node as a B here. Yes, B. E B are over. Then next in the sequence I have A. Yes, what is the sequence of A here? Triple ones are there. Okay, then trace the path of these triple ones. Yes, starting with root node. First one is there. Where should I move? Move to the right node. Yes. Again one is there. Where should I move? Again one means to the right node. Yes. I move to the right node. Again one is there. Where should I move? To the right. Yes. For triple ones, okay, this is the path. First one, second one, and the third one. So that for this node, I am going to label this node as A here. Okay, I am going to label this node with a symbol A here. A, yes, over. Yes, next in the sequence D is there. Okay, in the next sequence D is there. For D, what is the binary sequence? Double one. Okay, the meeting will end in 5 minutes. Okay, again fourth hour I am going to engage the same class. Okay, okay, all of you join to the same link. Here you see double for D. No, for D I have 1101. For D I have 1101. Okay, for this one, yes, one is there now, starting with root node. Double one means what here? For first one, second one. Again 0 is here. Where should I move? To the left node. Yes. Okay, after 0 I have 1. Yes. After 0 I have 1 means to the right node. Yes, is here. D. Okay, I have to write D here. I have to write D. Okay, for this one, okay, after getting this one, okay, with respect to the symbols, we have to construct the uh, binary tree. Okay, with respect to the symbols. Okay, here is B. B, E, D, A. C is not there here. C is not there. No, this is an extra thing here. Leave it here. Okay, first we have to construct full binary tree. Okay, again all of you join the meeting. Okay, the meeting will end in 1 minute. Okay, all of you join to the same link. Okay, I am going to continue with the same link. Okay, in the next session also. Okay, yes.